All right, short week this week. Okay. Only a 4-dayer this week. Okay. So today we're going to start K1, and that's going to be unit K is going to be all about exponents, and then unit L, which will be the last unit that we do, that's going to be all about systems of equations. Okay. Okay. So this week we're going to have intro to exponents today. Tomorrow we're going to deal with exponents with the same base. Wednesday we're going to deal with what is called the power property. And then on Thursday we'll probably have a little whiteboard practice on Thursday and a formative this week Thursday. Okay? Okay? I have when I'm done today, because today won't go very long. When I'm done today, I have one or two things to hand back to you. So all that stuff, and then I did not get the test corrected yet because I got a bunch this morning, so I knew those were coming in from various resources. So I didn't correct the test, but I'll get those corrected this afternoon. Okay? So thinking back, I know this is a long ways to think back, but this was first semester. Okay? So thinking back to first semester, what we did, please excuse my internet salad. We did order of operations. Okay? That E stood for exponents. Okay? So tell me, what does 3 squared mean? This right here is 3 squared, or 3 to the second power, or what? What else could we say 3 squared is? What does it mean? Three squared. When we were dealing with order of operations, what did we do when we saw 3 squared? Yeah. For those who didn't hear, she said, don't you multiply, wait, never mind. What does 3 squared? So, what do you think 3 squared means? 3 times 3? Huh? You see, what do you think 3 squared means? Something that's not up there. Okay, that's already up there. That's 3 times 3. Nine? Yeah, 9. Okay. Those are the 4 things that 3 squared can mean. Okay? Okay? 3 to the second power, 3 squared. That's how we read those. Okay? But really what it means is it's 3 times 3 and or just 9. Now with numbers, we can do that. Okay? With variables, which we'll get to variables later, we can't necessarily do that multiplication. So whenever we have a variable, then we lose that last number. We just have what it actually is equal to. Okay? Okay? So knowing that, Chloe, what does 4 squared mean? Other than being the greatest playground game ever. Ever play 4 squared? squared? 4 times 4? Okay. What is 4 times 4? 16. Yeah, 16. Okay. Michelle. 5 squared. What does 5 squared mean? 5 times 5. Hey, Zeus. What is 5 times 5? 25. Even with your AirPod in, you still were able to answer that. Okay, you ready for it? If 4 squared means 4 times 4, and 5 squared means 5 times 5, and on the last slide we had 3 squared meaning 3 times 3, what does 2 to the 4th power mean? So 2 times 2 times 2 times 2 times 2 times 2? Yep. Okay, so that's what that means. 2 times 2 times 2 times 2. 2 times 2 is times 2. You didn't know? That's plus. 4 times 2. 4 times 2. 4 times 2. 8. And then 8 times 2. 16. Okay. We could have also went 2 times 2 is 4. And 2 times 2 is 4, right? And then 4 times 4 is 16. Okay. Now, the problem is that when I bring the shape down a little bit, now our numbers are going to get pretty big. Okay? So sometimes we're going to have to use a calculator to evaluate. Do you have a calculator with you? You could come up here and grab one right now. And then you could tell me what 3 to the 4th is. While you're telling me what 3 to the 4th is, I'm going to write it out. This is going to be 3 times 3 times 3 times 3. Sometimes those numbers get kind of big. What did you come up with, bud? 81. Yep, exactly. And like I was just telling Anita, we could have also done this as 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 91. Okay. Why did you get a chance to do 6 to the 5th power? Now, you could do 6 times 6 times 6 times 6, right? Or there's a key on the calculator. I call it the caret key. It looks like this. Okay? On ours, it's this one right down here. Okay? On other calculators, it might look like this. Okay? And so what we would do here is we would type in the number 6, then we would type in that caret key, then the number 5, and then equals. What do you got?
I got 7, 7.
I'd say you were missing 1 7 there. So these numbers can get really big really fast, right? Okay. What did you come up with for 10 to the 7th power? 70? Because it would be 10, 10, 3, 4, 5, 6, 7. Yep, 7. Here, I'll borrow you my calculator. You tell I get 10 million. A little bit different than 7. Okay? Which we knew it wasn't 70 because here we didn't go 4 times 2 or 5 times 2. We didn't multiply those two numbers together. We took that base to that power, which means we have to multiply it by itself that many times. Okay? Alright? Now, what we're going to do today is we're going to condense expressions using exponents, and we're going to expand them. Okay, so we're going to condense and expand. When we condense, we're going to get smaller and smaller and smaller. We're going to get a nice, neat, pretty little expression. Okay? When we expand, we get these big, long things like we got here. Okay? Right? So what we have to do is we have to look for what are called bases. And bases are any number or letter. Okay. And for each number and letter, okay, and so for each different number or letter, we have to put that in our expression. So in this particular case, the only number, or the only letter that I see is X. Okay? So that means in my answer, I'm going to need an X. Okay? So if there is a base, a distinct number, or a distinct letter, if there's a base in the problem, I need it in my answer. And then I go back and I count up how many of those X's there are. Where did we leave off? Bryce, did we leave off at 2? Yes, we did, because Izzy was the last one. How many X's do you see? There's 4 of them, right? Here's 1, here's 2, here's 3, there's 4, right? And that total number of that particular base goes in the exponent spot. So this would condense down to be x to the 4th power. Okay? Not 4 times x, x to the 4th power. And that exponent, remember, is written smaller and it's written above the line. Okay? Don't write it like this. That's not an exponent. That's multiplying x times 4. Okay? We've got to write it smaller, and we've got to write it above in that upper right-hand corner of the base. Whatever base it is. Okay? Let's go to number 8. Natalia, we're up to you. We have a base of an A, right? Right? Okay. So that means my answer is going to need an A in it. How many A's are there? 3. So here's 1, here's 2, here's 3. So that means I need A cubed. Okay. Other Chloe. But I also have a base of B, correct? Okay. So that means that I need a base of B also. And how many B's are there? 2. So that's going to be B squared, or B to the 2nd power. Questions on that? Let's do one with a number now. So my first base is 4, right? But with numbers, I can multiply them out, correct? What is 4 times 4? 16. So this is going to be 16. Right? Then I look for my A, my next base. My next distinct base was A. Right? Okay, how many A's do I have? 1. So we are just going to write that as A. It's assumed that if we have a letter, that we have at least one of them. Okay, so we don't put an exponent of 1. Just like we don't multiply by 1. Okay, but if we did like when we were doing lines last week and week before and week before, if we gave a slope of 1 and then x, that was okay. Same thing here. If you just write it as A, that's fine. If you write it as A to the first power, that's fine too. Okay? Okay? Then we've got B's. Chloe, how many B's do we have? 6 of them? 6 of them? 6 of them? Yeah, 6 of them. So that's 16A, B to the 6th power. What I would like you to do now is I would like you to do numbers 10, 11, and 12. Stop there. Stop when you get to 12. Chloe W., what did you get for number 10? 4, because that's the 2 times 2. Okay? C to what power? To the 2nd power, yep. So how we read that is C to the 2nd power. Okay? And what did you get for D? D to the 3rd power. Yep, exactly. D to the 3rd power. Everybody get that? 4C squared, we could also write it as C squared, D cubed. An exponent of 2 is squared and an exponent of 3 is cubed. Half that, we just go 2 the power. But we can also do that for 2. Alright? What did you get for number 11? Power, yep. Times, yep. Bingo, yep, exactly. X to the 4th power, Y, Z to the 2nd power. I would concur with that. Good job. Colin, what did you get for number 12? Yep, exactly. 25 A squared B squared. Or 25A to the 2nd power B to the 2nd power. Good job. Okay. That is condensing. We're taking this big, long multiplication, and this only works for multiplication. If there was an addition sign somewhere in there or a subtraction sign somewhere in there, then all bets are off. We can't expand or condense it this way, and because of that addition sign. We got to do on either side of the addition sign or subtraction. Okay? So that's one way. Now, the other way is expanding it out. Okay? So x to the 4th is going to be x times x times x times x. We're going to write out x 4 times. Okay? Following that pattern, Urelli, we're up to you. What would x cubed, or x to the 3rd power, y squared, expand out to be? Just say, just go x times x times x times x. So you gotta say it up. You can't just say it. Yeah. Oh, okay, gotcha. Okay, so x times x times x, and y times y. Yep. Yep. Like that. Okay, we just write it all up. Okay. you now try expanding those two, or excuse me, those four. There's four. Go for it. So this one's going to start out with a 5. Then we've got an A, only one of them, and then we've got 3 B's. Next one's going to start out with a 7. Then we've got 2 A's and 4 B's. Then we've got a 6, 3 C's, 2 D's, and 1 E. Then we've got a C and 5 D's. Okay. And then we've got a home. Now, I'm going to ask, did anybody find today's material confusing? I want to make sure that everybody's confused. Okay? So, I am giving you 25 minutes. Okay? I fully expect, bless you, I fully expect that everybody in this room can turn in this worksheet by tomorrow's class. Right? Because you all know how to do it right now, because if you didn't, you would be telling me right now, and I could re-explain it to you. Okay? Now, there is some stuff from the last unit on this one, but you can always go back to your notes for that stuff.